let's talk about the confirmed dimension. Now, a confirmed dimension is a dimension that has exactly the same meaning and content when being referred from different fact tables. Now you have two different facts here, procurement fact and sales fact. Both of these are using a common dimension called location and date, right? So a confirmed dimension has exactly the same meaning and content when being referred from different fact tables, right? Now a confirmed dimension can refer to multiple tables in multiple data marts within the same organization. Now in this picture it is not clearly shown on that it is multiple data marts, but assuming this set is a data mart and this set is a procurement data mart, you're using the same dimensions between data marts, right? So for two dimension tables to be considered as confirmed, they must either be identical or one must be a subset of another, right? Now in this case these are the identical ones, right? Location, it will have the same attributes. There is no change which are specifically made for this fact or the sales fact, but it will have the same attributes, right? So there cannot be any other type of difference between these two tables, right? So why is confirmed dimension so important, or why is it specifically spoken about? Now this goes back to the definition of data warehouse being integrated along with other attributes like subject oriented, non-volatile, time variant, and the last one, integrated. Now integrated means that even if a particular entity had different meanings and different attributes in the source system, there must be a single version of this entity once the data flows into the data warehouse, right? So once we have the location details or the date details, then it should be used wherever it is required. It should be repurposed, right? Now if you look at the time dimension, the time dimension is a common confirmed dimension in majority of the enterprises and majority of the data warehouse implementations. Now usually the one rule to consider when the time dimension is created is whether there is a fiscal year in addition to the calendar year and the definition of the week, right? Now if you look at this data set here, you have fiscal year, right? And you have the month, day of the month, calendar day. Now these do not change, right? These are all standards. Now once these rules are set, the values in the dimension table will never change. For example, if you take October 10th, it is standard, right? You will not change the Saturday, year, calendar quarter, the month, calendar week. These are going to stay. These are not going to change, right? So usually there is quite a lot of importance given to time dimension when you're building the data warehouse, because it has to have all the attributes which all the data marts or all the data warehouses need within the enterprise. Now it is very rare that you use the same dimension in multiple data warehouse implementations within the enterprise which are run in silos, but it is possible, right? If there is a data warehouse project which is being used in one of the line of businesses, you can reuse that in your line of business within the same enterprise, isn't it? Of course you make a copy of it, but you can still use it because there is nothing which is going to change within the time dimension, right? Now time dimension is one of the easiest examples for it to become a confirmed dimension. Now not all confirmed dimensions are easy to produce as the time dimension, right? For example, let's take there is a customer dimension in an enterprise which is there for about, let's say, 15-20 years. There is high likelihood that different customer databases exist in different parts of the organization, right? Now this is a usual case because most of the applications which are remotely located or globally placed have their own silos, data warehouses or customer databases, right? Now if you take an effort to consolidate all of it, or to create a confirmed customer dimension by bringing all that data together, you need to do a comparison against each other. Rules must be set on what is the standard for that to be used in a single table, and there is a lot of exercise of cleansing and scrubbing the data, right? Because if you take a simple example of a merger, let's say there is a retail store which is purchasing another retail stores company. Both of those structures will be definitely different. If you have to combine them, you need to understand what are each attributes, how are your company's attributes connected to their company's attributes. Should you just include those as additional attributes, or is there a possibility to merge those attributes to your existing customer dimension attributes? If you have to do all this, what are the rules which you have to follow? What is a valid record? What is a non-valid record? What if there is a null for an attribute? How do you add all that? So there are multiple aspects of it. So all of your data experience has to come in there, right? So that's a whole different story. So I'm going back to the confirmed dimension definition. It is a dimension that has exactly the same meaning and content when being referred from different fact tables, or it is a dimension which is shared between fact tables within a single data mart or multiple data marts. All right, so that's a confirmed dimension. Junk dimension. In a data warehouse design, there are multiple frequencies where we run into a situation where you might have to use the flags or yes and no indicators from the source systems, or sometimes in the source systems, right? Now, through multiple brainstorming sessions and business analysis, we know that it is necessary to keep such information in the fact table, right? However, if we keep all these indicators in the fact table, not only we build many small dimension tables, but the amount of information stored physically in the fact table also increases tremendously, leading to possible performance and management issues, right? Now, looking at the data on the screen, you might know that it's not even a byte. Why are we talking about this? But consider a situation where you have millions of records being processed on a daily basis, and you have to keep all of these on your fact table, right? To fulfill that, a workaround was created, which is nothing but a junk dimension. In a junk dimension, we combine these indicator fields, whichever have the flag values, either yes, no, or 0, 1, or whatever flags you've set up in the project, into a single dimension, right? So this way, we'll only need to build a single dimension table, and the number of fields in the fact table as well as the size of the fact table can be decreased drastically, right? All you need to store in the fact table is the junk ID, or the primary key of this junk dimension, which is connected to your fact table. The moment you want to know about a particular product's delivery, you get the foreign key ID from fact table, which is junk ID in this case. Take number 1, for example, and you will see if it is picked, packed, shipped, delivered, received, returned, or refunded, right? So based on these flags, you can conclude what has happened to that particular sale, if it has been refunded, returned, or received by them, how many of them are not received, and what is the plan for them to send it. Is the customer is going to pick up, or our delivery team going to deliver it again, right? So those are the things which can be determined separately if you have a junk dimension. So the content in the junk dimension table is the combination of all possible values of the individual indicator fields. It is usually the flags like yes, no, male, female, 1, 0, active, inactive, whatever acts as a flag within your setup can be clubbed all together and put it in a junk dimension. All right. Degenerate dimension. Now, according to Ralph Kimball, in a data warehouse, a degenerate dimension is a dimension key in the fact table that does not have its own dimension table, because all the interesting attributes have been placed in analytical dimensions or existing dimensions. The term degenerate dimension was originally set up or coined by Ralph Kimball. As you can see in the figure, you have two dimensions and a fact, right? These two dimensions are connected using the foreign key. Now there is an attribute called sales transaction number. Now this is not present in either dim date or dim geography. Dim here is nothing but a prefix for dimension, right? Now if you go back to any of our previously discussed schemas, look at it here, you have four dimensions and you have foreign keys for all four of them. That's what is been there in all the types of schemas or the examples we have seen. So you have product, client, shop, and date, right? Now if you look at the Galaxy schema, you have the same thing again. So whatever is connected to the fact, there is a foreign key within the fact along with the measures. So when you come to this particular example, which is a degenerate dimension, you have a measure which is sales amount. You have two foreign keys connected to two different dimensions. Then where is this sales transaction number coming from, right? So this sales transaction number is considered as a degenerate dimension, right? So these are the dimension keys in the fact tables which are not related to any dimension table. Instead, these degenerate dimensions are used to link back to the source system for any data validation. These can connect to your raw source, your source from which we are pulling all this information. Your OLTP systems, which is generating the source files, or your CRM systems and multiple things, right? So to simply put this, these are the natural keys in the source system, right? Like the transaction number, sales order number, shipping tracking number, etc. Right? So clearly the business users will not be interested in browsing the facts on degenerate dimension because, for instance, total sales by total sales order number doesn't mean anything, right? But if you're using it for any reporting purpose, and if you have to come up with any comparison between what you have got from source and what is there at the fact table, these might come in handy, right? Now the three different dimensions which we spoke about, which is confirmed dimension, junk dimension, and degenerate dimension, it is not mandatory that you use all these in your project. It is all driven by your data model and the requirement from business. If it is required, only then you use. Maybe you're already using it, but you wouldn't know the terms, but these are the ones based on which you can use them. All right, so that is degenerate dimension. Role-playing dimensions. A role-playing dimension is the one where the same dimension key along with its associated attributes can be joined to more than one foreign key in the fact table, right? For example, a fact table may include foreign keys for request date, order date, ship date, arrival date, and assembly date, right? But the same date dimension attributes apply to each foreign key. So you can join the same dimension table to both foreign keys. Here, the date dimension is taking multiple roles to map request date, order date, ship date, arrival date, and assembly date. And that is the reason we call this as a role-playing dimension, right? Imagine it like this. You have a dimension table, right? In the time dimension table, you have date, date description, month, month description, day, day description, and then you have all this request date, order date, ship date, arrive date, and assembly date. Now, each of these dates which you can see on the screen can be a foreign key to some other dimension or some other fact. Usually it will be a foreign key to a fact, right? But you can also link it to any hierarchical specific dimension tables. So these 5 attributes become foreign key to different fact tables. It can be one or more than one fact table based on the design, right? Now, instead of having 5 different dimensions, all we are having is 5 different attributes within the same dimension. Now, in those kind of situations, it is called as a role-playing dimension. Time dimension is the best example for the role-playing dimension. Based on the business requirements and based on the design, there can be any table which can hold more than one attribute, which can act as a foreign key to a fact table to get more reference data. In those kind of situations, it is called as a role-playing dimension, right?